All right, so we are finishing up or doing our last installment of properties of functions and functions of vocabulary. We have already covered continuity, increasing, decreasing, and constant, intervals and functions, boundedness, local and absolute extrema, symmetry, asymptotes, and limit notation. And so now, in this video, we're going to talk about end behavior and also use limit notation again. So let me scroll all the way down to the end of our page and say, here we go. So the end behavior is the behavior of the graph, or the behavior of f of x, at the edges, or ends, edges of the graph. That is what happens as we go to positive infinity, or as we go to negative infinity, as x increases without bound, or when x decreases without bound. What happens as we get very big or very negative, very positive, very negative? So we'll start with the right hand behavior. So this is the green in that picture. So what does the function value, also known as f of x, what does f of x approach? What are our y value? Let me write down here our y value, because we know that our function value and our y value are the same thing. What does it approach as x gets very positive? Now there are a couple things that could happen here. Draw a little graph here. As we go across here, it could go up, increase, go towards positive infinity. It could go towards negative infinity, or it could, somewhere in between, go to some number, which we'll call b. So it could go to positive infinity, negative infinity, or b. We don't know. So I'm just going to pick one for now and talk about if it goes there, how do we write that? How do we express that in math? So, limit notation. If a function increases, well, yeah, that's good enough, without bound, that is to say, it goes to positive infinity, as x approaches infinity, we would write in limit notation the limit of x approach. Well, what is x approaching? X is approaching infinity, and we want to find out what is the function value doing. What is the function approaching? In this case, we said it's increasing without bound, so we would write the limit equals infinity. Or you could write positive infinity if you wanted to. All right, now let's talk about, so we've talked about right end behavior, let's talk about left end behavior. Very similar. I'm going to deal with the red. So what does the function value, again, our y value, approach? What does our f of x approach as x gets very, well, we're not getting very positive. We're not getting very small. We're getting very negative. These are very large numbers, but they're very negatively large. So we need to talk about what does that do? Well, just like before, it could go down, could go up, or it could go to some number in between. Well, let's talk about if it goes, in this case, what happens if it goes to some number in between. So if a function approaches, I can barely spell, let me rewrite that, O-A-C-H-E, approaches a value y equals, let's say, 3. Oftentimes you see this with a horizontal asymptote. If the function approaches y equals 3 as x approaches negative infinity, how would I express that? Well, I would write the limit as x approaches negative infinity of f of x equals 3. So we see that as we are going left, let me box this in here, this here says what happens as we go left. And then we have this part over here that says what value, what height it goes to. What does the f of x go to? So I'm going to draw two pictures here for you, if I can get. And what I'd like you to do is to tell me what the end behavior is. Use limit notation to write what happens left hand and right hand behavior. So you're going to have four limit notations that you're going to be writing here. So if I draw a graph, let me get a nice color. What color? I'll go with black. And it goes down and we come up. So here we go. There is our first graph. So here we'll call this number 1, end behavior number 1, and end behavior number 2. We might have a graph that looks like this. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Negative 4, 4, 4. 1, 2, 3, 4. That's negative 4. So we'll have this come to go off this way, and then it'll come back up, go across, come back down, almost horizontal. So we have a line here, right here. So, what I'd like for you to do now is to take a moment, look back over your notes, and tell me what is the limit notation, the end behavior in limit notation for these two functions. Have a pause, and actually, I'd like for you to come to class tomorrow, or our next class, and we can talk about going over that. All right, so that's the end of our introduction to function vocabulary and properties of functions. I hope you enjoyed it, and see you next time on the next video. Bye-bye.